Okay, leaving where we picked off yesterday. So we had just gotten this graph, and we need the equation now. You are told that you need this equation to be using the cosine function. And now I'm trying to get my pen to work again. Pen, I just need you to last me 2 more weeks. Come on. There we go. All right. So I'm underlining cosine to emphasize that this is asking for a cosine function. With cosine, it begins a cycle at its highest point, and we can see that we have a highest point right here. And that point is time 2 and position 13. Now, there are several things that we're going to need to put together. Let's start with the vertical items because the vertical items are easier to play with. With the vertical issues, I have a shift vertically as well as a stretch vertically. That vertical shift is exactly the same number as the midline. And we had found that the midline was 6. So this is going to be plus 6, and D is taken care of. Now A is going to be a positive number if I begin a cosine cycle at the top. And I am beginning at the top. So that means that I just need to write down a positive number, and that number is the amplitude. The amplitude is the distance from that highest point to the midline, and also the distance of the lowest point to the midline. And that distance is 7. And now I want to take a moment to go back to this word problem and look at where that 7 and 6 are coming from in the word problem itself. We were dealing with a water wheel, and that water wheel is watching this point P on the wheel itself and watching where that point moves as this water wheel turns. The number we just put down for A was 7, and the D was 6. Now the A is the amplitude, and if you look at this word problem, you should notice that the radius of that circle is 7. Would it make sense that the radius of our turning circle would end up being the amplitude of the sinusoidal graph? Let's look at that graph again. And keep in mind that the x-axis is representing time. The y-axis is representing just the height above the water. So it's just that vertical distance alone of height above water. So we're allowing time to just roll itself out. And we're watching that one point on the edge of the water wheel is above the water at 13 feet above the water. And then it heads down until we are 1 meter or 1 foot under the surface of the water. And then we come back up until it reaches again that height of 13 feet above the top of the water. And now look at that wheel. And I'm hoping that you will really think about the connection between that sinusoidal graph and what's going on with this circle, and specifically just this point's vertical distance as the point rotates around. So again, that vertical distance d, when my point has moved over here, that's going to be that distance. When my point has moved all the way to this position, that distance is this. Now, I'm just realizing right now that I have the letter D for distance, where this was representing just my vertical shift in the graph. And so I should probably make a different letter for this, maybe H for height above the ground. But do you see that amplitude and vertical displacement? Amplitude is the radius of that circle. And what do you notice is so important about this shift? And what you want to notice is that vertical shift is the location of the center of that circle. So keep that in mind when you're setting up your equations, that the amplitude is the same as the radius of a circle. The vertical shift is the location of the center. The center of that circle. Okay, those are the vertical issues. I now know my A and my D, and I'm going to unhighlight those. And now we're going to focus on the horizontal issues of what is the B and what is the C. And I'm hearing some, okay, not hearing it anymore. Anyway, now, do you remember that when I multiply my input by that B, that's giving me information about the period of the graph or the frequency? So I need to figure out what is the cycle length, meaning if I go from the time that I begin a cycle to the time that I finish a cycle, how much time takes place? And the amount of time that takes place is 10 seconds. And what you want to realize is in the visual picture here, with just knowing the radius being 7 feet and the center being 6 feet above the surface of the water, with that information, you can see the vertical issues of the sinusoidal graph, but you can't see the horizontal issues of time. Now, one thing that's really convenient is this. The frequency, if you know the frequency, that is the B of your equation. Period is 1 divided by the frequency. The frequency is that you do 1/10 of a revolution per second. that B is 1/10. It is actually the frequency. Now, another way that you may be shown how to do it is the period of the graph is equal to 2 pi divided by that B. And we were looking at the fact that the period of the graph is 10 seconds. So I multiply over to the left by, I just realized with the frequency I didn't involve the pi issues. So hold on a second. Multiply the B over to the left. And so that frequency is actually multiplied by a 2 pi. That's what I should have said. But also you can get the B value using this equation. But I also want to write down that B is equal to the frequency multiplied by 2 pi. Okay, then let's take a look at C. C is my horizontal shift. So it's looking at where does time begin. Now, time begins at an awkward place. But what I want to look at is, for my cosine graph, what is the time that I'm at my highest point? That time that I'm at my highest point is going to give me my horizontal shift. And it's 2 seconds. But I've got to remember that it's always opposite operation when I'm dealing with inside the function with an operation to the input variable. I need to have a shift to the right 2 seconds. Now, normally I think of moving to the right as adding 2. But in the equation, I actually need to have t minus 2. And then let me say again that for the period of the graph, you found that the period was 10 seconds. If I want to find what I'm multiplying my input variable by, I need to look at what do I need to divide a normal period length of 2 pi? What do I need to divide it by to get that period? And so now I have everything I need for my equation. My height is equal to 7 multiplied by the cosine of, and as long as I have a parentheses here with my t minus 2, then this 2 pi over 10 is the number that my graph's original x-coordinates will need to divide by to get to these x-coordinates, or t-coordinates in this case, and then plus 6. And that is an example that has everything in it. And I want to just show you the issues here with, we talked about the, let me change this to H again, the A and the D for the vertical issues. For the horizontal issues, you're looking at anything that tells you about how quickly things are going. It's all about time. 6 revolutions per minute was needed to understand the time elements. Also, the fact that 2 seconds after the stopwatch started, point P was at its greatest height. That actually gives you the shift. So knowing about when the start time is deals with the horizontal shift. Which I was using the letter C for, where it said T minus C. Knowing the frequency or the rate at which the wheel is turning, knowing something about that is what you're going to use to determine the number that the B number that you need to multiply by time. And just keep in mind the formulas you can use to find B. And I'll show that for one last time. Either use the period is equal to 2 pi divided by B, or the frequency multiplied by 2 pi is going to give you the B. That is the end of example 2. And now we hit example 3. And I've got some prompts to help you get to the point where you can graph the sinusoidal graph. Here we go. So we are told in Johannesburg in June, the daily low temperature is usually around 3 degrees Celsius. And the daily high temperature is around 18 degrees Celsius. Now let's focus on the fact that that says the daily low temperature and the daily high temperature. What is that telling you that is very valuable? So what I'm going to do is I'm going to write down the high temperature, 18 degrees, the low temperature, 3 degrees. And then there's a reason why I'm asking you here for what is the average daily temperature. So the average daily temperature is looking at what is halfway between the daily high and the daily low. So if I'm looking for average, I'm going to take that I have 2 numbers and I want the average of 2 numbers. So I add them together and divide by how many numbers I added. And that gives me a fraction. So not necessarily what we wanted, but that's going to give me 21 halves, which is 10.5. So 10.5 degrees Celsius. Now let's go over to the graph and let's put down those 3 numbers for the y values, because the y values are the temperatures. The high is 18. The low was 3. And the average temperature was 10.5, which would be about there. And hopefully what you see is what that's creating is we've got a midline. And I'm trying to make horizontal dashes. And we also know where our high point occurs and where our low point occurs. This is a lot of information. In fact, with this information alone, you can determine the amplitude and the midline. The amplitude is the distance between the midline or the average and the high, which is also the same as the distance between that midline and the low. So what is that distance? We can take the high and subtract the midline, the average temperature, and that gives us what number? 7.5. So this distance is 7.5. I have my amplitude, which is going to help me to determine the multiplication number outside the function. Now, keep in mind that this number is either going to be positive the amplitude or negative the amplitude. And we'll figure out the positive or the negative later. D is the shift vertically, which is really just where's the midline. So D is going to be 10.5. So I'm going to be doing plus 10.5. And I've got half of my equation already. And also I just realized I didn't put down the midline number, 10.5. There we go. So we actually have all our vertical information just from that. The horizontal is a little bit trickier to find. So now let's keep reading and see what other information we have. It says the temperature is typically halfway between the daily high and daily low at both 10 a.m. and 10 p.m. So what that just said that I am halfway between. In other words, I'm at my average daily temperature of 10.5 degrees at 10 a.m. and 10 p.m. What we can decide to do is look at number of hours past midnight and use that for my T numbers because I've got the AM PM problem and I need to get rid of the AM PM problem. So that means that I'm going to use T equals 10 for the AM. And what would 10 p.m. be? Ten p.m. would be 10 plus 12, 22. And let's keep in mind the units. We're dealing with hours. So 10 hours and 22 hours, we are at our midline. I'm going to come over to the graph. 10 and 22 are times when my graph is at the midline. So I'm going to plot those points. Then I need to keep reading because I still need to figure out what are the times when I'm at my high temperature versus my low temperature. But what's really nice is by just knowing these two, what is the time that is halfway between 10 and 22? And if you need to, you can literally count 2 units, 2 units, another 2 units, another 2 units, and then another 2 and another 2, and I hit my middle time. I can also do it by averaging the two numbers, which means add them and divide by 2. And you can see that we get 16. Now, what I know here at this point is that at time 16, I am either at a high or a low, but I need to read a little bit more information to determine which of those two it is. So now it says the temperature is typically halfway between the daily high and daily low at both 10 a.m. and 10 p.m. And the highest temperatures are in the afternoon. In other words, this is going to be a high temperature because that is an afternoon time. That is 4 hours after noon, so it's in the afternoon. And I'm going to plot that point because we now have that at time 16, we are at the high point of 18. And do you see how much is right there in the graph? For some of you, that may be enough where you've got the whole thing done. Because you should be aware that what this is showing is this much information is half of a cycle. And I can go either backward or forward and just mimic that or just copy that, but flipped upside down. And it's your choice as to which direction you would prefer to go. If it takes me from 10 to 22 to create half a cycle, then that means that 12 hours is half a cycle, so 24 hours is a full cycle. Which would make sense if I'm talking about daily or temperature throughout a 24-hour day. So if I want to, I can start at the 22 and go 12 more hours. So where am I at if I'm at 22 plus 12 more hours? That puts me at 34 hours. And that's going to be when I finish a full cycle. But I really want to always look at the quarter marks of each full cycle. I have a beginning of a cycle at 10 and an end of the cycle at 34. The first quarter of the way through is at 16. Second quarter is the halfway point of 22. And then what is going to be the third quarter endpoint? And perhaps what you see is that you have 6 hours between each quarter cycle. That means 22 plus 6 hours takes me to 28. And now when I bring all of this together, When I'm drawing a sine cycle, it begins at the center, then goes to its highest, then back to the center, then it goes to its lowest point, which we had found to be 3, and then it goes back up to its center at the final time. And that would be one cycle worth of a graph. Now let's look at the rest of the information, because what I want you to understand is when you do the homework, I have a guided beginning that's supposed to help you to organize all your information. And when you organize your information, you're going to have an easier time thinking about where things are located in the graph, which will then help you with getting the equation. So this is now saying state the number of hours past midnight that each of the following occur. A daily high temperature, we found that to occur at 16 hours after midnight. The daily low temperature, you can either see that as occurring at time 28, or you may have found an earlier time that it happened. If you wanted to see the earlier time that it happened, you would look at that is going to be 1/4 cycle before this midline point at time 10. 6 hours before time 10 is time 4. So you would be correct in using either time 4 or time 28. When you look at the homework assignment, in the homework assignment, I'm going to ask you for 2 different times when it's at its low temperature and 2 different times when it's at its high temperature. And that will, and so I just showed you how to find 2 of those. If I needed to know another time that I was at my high temperature, I would just need to realize that that's going to be 1/4 cycle beyond where I just stopped, because right now it's about to head up to its highest point. So 6 hours past 34 will take me to time 40. But I could also look at it as 24 hours before this time. Although that's going to go off the grid that I have drawn here, but that is still a correct answer. My high point occurs at time 16. It occurs again at time 40. But I could also say that it occurs at the time that is 16 minus the length of a cycle, 24 hours. 16 minus 24 is -8. So you could have said -8 as well. Now I have the graph. And let's take a look. The next question is, what is the period of the graph? We found that the period of the graph is 24 hours. And I want to know the B number that goes here. So I'm using the equation 2 pi divided by B is equal to the period length. So I'm going to multiply both sides of my equation by b. So I will have 2 pi equals 24 times b. Then I need to divide both sides by 24. So that means that my b is equal to 2 pi over 24, which I can reduce 2 pi divided by 12. So now I have the answer that b is pi divided by 12. And then my c number. The thing about c is you can choose to start your cycle at different moments. If we're going to use sine, that means we need to look at a time when we're at our midline. And then I can choose that if I would prefer to use a positive amplitude for my A, then I want to look at when I'm at a midline on the way up. Here is a point where I am at the midline and I'm on the way up. I can use positive 7.5 for my A. If I do a shift of 10 units to the right. And remember that the standard form of the equation is written as x minus to deal with the fact that we actually subtract the 10 if we're moving right 10, and we would want to be adding 10 if we were looking at shifting the graph left. But if you put down for that actual c itself, the point in time where you begin a cycle, then you can just fill it into the equation just as is. Now, we're almost done. Write that trig function. Now it says write a trig function that models the temperature T, capital T, in Johannesburg, T hours after midnight. So that means capital T for temperature with respect to time, lowercase t, is equal to positive 7.5 times the sine of pi over 12 times x minus 10. We have 10 minutes left. And then plus 10.5. And realize that is a lot of information in that equation. But if you process it slowly, it's not so bad. Let me show you the classwork answer for that problem. And I want to point out that this is not the only equation that is correct. The way that you might differ is if you change the starting time, it's possible that you will change this to being a negative 7.5. So those are the two things that you might see different if you look at it from a different start time. But it's still the same equation. All right, I'm going to stop the recording.